All right, good morning, everybody. It's 10 o'clock here in Knoxville, rainy Knoxville. You've got myself, Mike Yob, and Will Overstreet here with us, and Mike Torville. He'll be available at the end for questions. Some housekeeping, just like 2 weeks ago. There's an area in the top right of your screen that has a drop-down where you can type in questions. Everybody is on mute at this current time. Please use that questions pane to record your questions at the end of the presentation. We'll address them as they come in. So with that, we're going to get started. This is the GS2 versus the legacy processor review, why the GS2 is better than the legacy. We'll go through a quick overview of the GS2. As such, we'll do the legacy processor as well, and then get into the comparison between the two and why the GS2 is better. And we'll close with some questions. Should only take about 20 minutes. I think we've got about 10 slides. Really appreciate you guys getting on the call with us. You know, time is money, so we really appreciate that. The GS2 processor overview. So a couple of things that I don't know if we've done a really good job of touting with this, but the GS2 was designed by the world famous IDEO company. They were involved in a number of really innovative products, starting with the Apple mouse back in the 80s. But their process is pretty heavy. The design process, they conferred with customers, distributors, industry experts, and competitors to apply the GRIDSMART standard to a groundbreaking design. This process took about 6 months, and it really led to the processor as it looks today. The processor is housed in an investment cast single-piece GRIDSMART tough enclosure. It's made out of aluminum. It's got a very simple design that provides maximum uptime by minimizing the number of parts. So through IDEO and our engineers in-house, Mike leading the way there, we've made sure that the processor was simple compared to the legacy one. And it's got a modular design, which means that it's field repairable with very limited tools. In addition to that, it's got flexibility designed in. What we mean by that is it's only 1U high, so it can be rack mounted, it can lie horizontally, or it can stand vertically. So in the panel, depending upon where there's room, we've designed in flexibility so it could be placed wherever the room is for it to be placed. The front panel shows phases, calls, and status lights and bright multicolor LEDs. Suppliers for the components of the processor were qualified in redundancy. That meant that we went back through and made sure that whoever we were selecting as our supplier had the right what's the word I'm looking for? The right credentials. Ethernet connection enables the system to be attached to your network, and also we've got Windows 8 operating software in this processor. Comparatively with the legacy processor, I mentioned IDEO for the GS2. This one was designed in-house by electrical engineers. It's housed in an aluminum enclosure that's more the industry standard with a front panel LCD display. The industry-based design requires the user to remove a dozen screws to open. And if you recall, I mentioned that the GS2 does not. Utilized older technology that was near end of life. What we mean by that is the technology inside the box was much older than the current GS2 technology. And it's almost 3 units high, and it can only be installed one way, as you can see in that photograph. And it utilized Windows XP as the operating software. So with that, I'm going to turn it over to Will, and he's going to go through why the GS2 versus the legacy and some of the things that are your unique selling points for you and your team when you go out in the field.
Yeah, just some of the other big things we wanted to point out is just, why do some of those things? It's great to make something look nice, but why was the thought process put in to do those things? And we designed it with 80% less parts than the LP. As you can see from those two pictures, the top being the GS2, the bottom being a legacy processor, you can see the difference in the number of parts just by looking at those pictures. And one of the big things we removed, we went from 3 fans to 1 fan, which was big because there was, failure of fans could be an issue in the legacy processor. We got more efficient in internal connectivity, and the modem was inside and not a separate piece of equipment. So, think of it as if they wanted connectivity, they'd have to buy a modem in addition to the legacy processor. This actually has it all built in. It's the latest and greatest hardware components. It's the most up-to-date processor that we could put out there, and all of the parts and the things that are in their first 25% of their life. So we're not having to worry about somebody dropping support for a particular part or system or operating system at this point in time. We did full thermal analysis and conducted by third-party testing groups. And then over that, just in general, how the customer sees it, there was always a problem with the legacy processor. People saying the space in the cabinet, the real estate in the cabinet. There were certain people you couldn't sell to because of the size of the legacy processor. It couldn't fit in those cabinets. So we made it 75% smaller so that it's opened up more marketability and more markets for us. And also just gave the customer what they needed, which is more flexibility in how they were going to install it. With that, the LED lights on the front of the unit to show the phases and calls. We went with LED because we had better visibility over the LCD. If you've ever seen a little bit of sunlight going on an LCD screen, it all of a sudden becomes obsolete and hard to use and look at. The LEDs also will last a lot longer. LCD screens over time, a year or so, will start fading, and you'll start being able, once again, something that starts off as a really great, easy-to-use tool can become useless. The interface for the TS2 is a standard. One of the ways to save room was not to build in both at the very beginning. So that's why we made a card to be able to flip out for the TS2, the TS1 protocols, so that, we know it's going into one kind of cabinet. It's not going into multiple. So this was just an easy way to reduce a lot of that size and complexity. It is ITS compatible to GS2, and it requires no tools to open the box. It's easier to fix in the field. If something does go wrong, that's always an advantage, that it's not hard to go change something out and do something. Now, we know there's been some recent things that we've been sending out TSBs on that we found out along the way and have tried to communicate with everyone, and we need to do a better job of that in the future. But in doing that, we have fixed these issues. And so one of them was the grounding connection. This was a very rare occurrence, but we wanted to be proactive and prevent this from happening from other people. Once we had found it, we understood that we needed to add an internal grounding wire and to ensure that there was a good grounding connection. We've seen very positive results with where we were having this issue, and it has been fixing it on a very high rate. I think we're at 100% of the cases we had, it fixed it. Antenna adapter, there's a free upgrade proves antenna reception. I'm not sure, Mike, what you meant on this one right here, the free and upgraded.
That's a typo, but okay. There was a free upgrade that improved antenna reception that we sent out. That was part of that TSB.
Okay, that's right. And then the shielded cable, we had been selling it. We needed to update our spec on that. We had just seen over time that more and more things with power and data coming through a conduit with other power, things with power running through, that just made more sense, and that had improved our standards. This was something we were slow to react. We admit it. We should have reacted faster. We should have been more communicating out front on the ball in this one. Once we realized our mistake, we did our best to get it out there and get it in front of everybody. We've seen this has been an improvement, and it's helped our customers as well.
And there'll be more action on that as in the days and weeks to come. So bear with us.
Yeah. So with that, we kind of want to go over that just to recap. We know the GS2 has been out for a little over a year, but we just wanted to get back in front of everybody, kind of give a refresher, talk about some of these things, and be able to have Mike here to answer some of your questions. So with that, we'll go to our questions.
And again, folks, if you've got any questions, please feel free to type them into the questions pane, and we'll be happy to address them. And so far, we have none. We must have done a good job.
Mike, is there anything you'd like to add that I may have stumbled around in those last few parts that you may do a better job of explaining than me.
Well, no, but going back to the recent issue, so I'll go back through all three of them.
That's right. Yes,
just to add a little more color to it. But on that grounding connection, and what had in there, we were relying on a mechanical connection to give us an electrical connection there between the board and the grounding stud. And we found that in some instances that wasn't what it should be. So adding that wire basically eliminates that as a possibility. And what we had a customer report is they had an issue with, and it had to do with the SMCH. And when they would ground the SMCH, they would see some camera issues. And what we traced that back to was the fact that we did not have a good earth ground in that particular unit. When it was first reported, I had to go through 6 units before I found one doing the same thing. And then once we had replicated the problem, we were able to track that down to that connection. So we feel that that's going to take care of that. On the antenna adapter, there it has to do with the connection. So what we've got is an adapter that changes it's basically a gender bender, if you will, gender changer for the top antenna port. It'll go ahead and allow you to connect your antenna there, and that'll boost your signal. And that was on a limited number of the initial systems that went out. You can refer to that TSB on our website in the support section to get those specific serial numbers. And then on the shielded cable, and just reinforcing what Will said there, industry best practices is to use shielded cable in a harsh environment like you've got at an intersection. Network cable is just susceptible to picking up transients and noise from the high voltage stuff that's out there, whether it be the signal heads or just something powered in the cabinet. So by putting that shield on there, it just keeps those low voltage signals on those data lines from getting the noise coupled in. So
and to be clear, that this has been our protocol even prior to the GS2, right? So there was still issues with past processors, right? It was the most immediate past legacy processor or processors before. So this isn't specific to the GS2. This is an industry standard.
Right. It is not specific to the GS2. So if you have legacy processors out there exhibiting some of those symptoms based on noise, it's going to help you there in the same way as it would with a GS2.
Well, thank you, Mike.
You're welcome.
All right. Well, I guess there are no questions. If you guys think of anything after this call, feel free to reach out to your RSMs, to Will, myself, or Mike, and we'll be happy to answer your questions. Again, we really appreciate you guys jumping on the call with us this morning. Hopefully this was helpful. And with that, we're going to sign off. Have a wonderful day, and we'll talk to you soon.